So I thought I would take this opportunity to tell you what a flat iron is at the very simplest. I did a video for the hot plate and you people have loved it, so I also want to keep this very simple. That is because the flat iron is basically a sibling of the hot plate, because this one provides heat for ironing while the other one provides heat for cooking. Anyway, a flat iron is basically two things at the very basic. If you really want heat out of it, we have a resistance wire, the one that generates heat, and then we have a conducting wire, one with extremely low resistance to bring power to the terminals of the resistance wire. Now, whenever you supply power, in other words, you plug in your flat iron into the socket, power will arrive to the heating elements terminals, end 1, end 2. Of course, this is continuous through the center, and therefore this will heat up. However, if you apply power constantly at the ends of the heating element, it will generate heat perpetually to a point that it will become red hot, and even this aluminium casing will literally melt. You don't want that to happen because you're trying to iron. Of course, by the time the metal is melting, your cloth will have gone along with it. Anyway, and also you also risk a fire. Now, how do we sustain or make sure that the temperature never goes beyond a certain level? Most ironing tends to happen between 150 degrees Celsius to rarely above 220 degrees Celsius or centigrade. Anyway, so what helps us achieve that is what you call a thermostat. Now, this thermostat is basically an application of the bimetallic strip. Bimetallic strip is two metals of different thermoconductivity or thermoexpansivity. Whenever you apply heat to a metal, it expands, but different metals expand by different amounts for the same amount of temperature change. Let's say, just imagine this was one metal, the upper one was one metal, and they were fused together, and the upper one for some reason expands faster than the lower one, so it will cause this to usually bend downwards, and we take advantage of that to make contact. When it's not bent, it is making contact. When heat builds up and the upper metal expands more, then this will bend downwards, and that contact that was above with the above kind of breaks down, and that's what you're seeing right here. So if you look at this, you can see that power comes from this terminal and then enters through here to the top, but at the bottom here there's some bit of contact to be made in between those 2 points. I do not know whether you'll be able to see, but somewhere there. So what happens is, when heat builds up, assuming you've chosen to iron cotton, which doesn't, let me say silk, which doesn't need too much temperature, actually polyester, which doesn't need too much temperature, then in that case you will rotate this and set a certain temperature. Of course, this is connected to that plastic dial, and you set a certain temperature. So that temperature is set because now, remember, as heat is building up, it's trying to bend and make this to break contact. But this right there is applying a pressing force, a predetermined pressing force, which this metal should be able to overcome in order for it to break contact right there. So the more the force applied here by you turning clockwise, the more heat is required to generate enough bending to allow this to break contact. And when that does happen, so this helps to maintain temperature within a certain range. In fact, when it breaks contact and the temperature falls, the metal straightens again, and then contact is re-established. When the temperature builds, it bends and then breaks contact, so it just keeps it within a certain range of temperature, safe enough for you to iron your silk cloth. So in essence, if you really want to fix your flat iron, there are basically 3 things to check out for, which tend to fail. 1, begin with checking the heating element. Okay, I'm assuming you've already checked the fuse in the plug, and then you've checked the wire coming from the plug straight to these contacts to see if they are not broken anywhere midway, and that you can confirm by using a continuity test where you place your multimeter in continuity model. Actually, continuity simply means you're trying to check if the wire is continuous. And if I put a current through here, it will come out through this side. So that is continuity, and if a wire is broken, that will not happen. So check for broken wires by using continuity test. And then now, if all those are okay, when you get inside the flat iron, the first thing to do is to test the heating element. Is that wire broken or not? Because anyway, it's just a fancy tungsten resistance wire, about 30 to 50 ohms depending on the wattage of your flat iron. If it is a 2500 watts, it's most likely going to be 30 ohms. If it is a 1200, it's most likely to be 60 ohms, or sorry, 50 ohms or something. Anyway, that being said, having tested for continuity, the next thing, if that is good, you will also test continuity across the thermostat. But you have first set the temperature at maximum, in other words, rotate it clockwise until the limit. That will ensure that it will always or have already closed contact, and then you'll test. If it is not continuous, then you have a challenge with your thermostat, and that can be one of two things. This pre-tensioning pressing thing needs to be loosened, and you can tune that by turning this clockwise, and that will lessen the pressing force on this. Okay, having done that, you can always test, but there are times where this is totally dead and you simply have to swap out this. At times they're not swappable, but anyway, I think that's much of it about a flat iron that you need to know. Nothing very complicated, nothing very complicated. Oh, then there are actually others that tend to take advantage of a temperature fuse. Should the thermostat fail, there will be a temperature fuse somewhere attached close to the heating element, whereby when power comes, passes through the thermostat, passes through the temperature fuse, and then goes to the other terminal of the heating element that didn't have direct connection to the neutral, to the power. And when that normally steps in when this has failed and the temperature has built to unsafe levels. For instance, let's say 250 degrees Celsius. No one irons at that amount. So at that point, that thermal fuse will blow such that it protects the flat iron from melting, and also you will actually at that point your cloth will have burnt anyways, but protect the flat iron from melting and dying entirely, of which you replace that thermal fuse. Some people just bypass it and make sure they fix the thermostat, but that is scenarios whereby you cannot trace it. Anyways, it's advised to always find it and replace it. Thanks for watching, and see you in subsequent videos. I'll be delighted. Sorry, I haven't uploaded in a very long time. That's that for a flat iron, and see you.